Molecular distribution. Understanding not only the type of molecule, but also how they are distributed and their size in a polymer is essential for a better understanding of a polymeric material. The way the chains are distributed, including how they are entangled, significantly alters several mechanical, optical, barrier, and electrical characteristics. For example, a same molecule can have totally different properties. Let's see the case of high-density polyethylene and low-density polyethylene. They are all polyethylene, right? But due different molecular weight distribution and entanglement of the molecules, they behave totally different. It is possible to calculate the average molecular weight or the weighted molecular weight, which is more practical and realistic. There is an important concept here called polydispersity. It's an index that indicates the difference between the size of molecules. Polydispersity closer to 1 means that the molecules of the polymer have similar sizes. Meanwhile, if the polydispersity is much different from 1, it means that the molecules of a polymer, they have various sizes and weights and different weights. Let's see the next slide with those graphics, broadband and narrowband. Broadband means the polydispersion is farther from 1, so the molecules of the polymer have different size and shapes. This implies that this polymer might have a lower crystallinity, lower rigidity, but also stretched more because you have larger molecules and smaller molecules. So it's easier to stretch this material a little bit more. The density also have a trend to be lower. So in the case of a narrow band type of polymer, the polydispersion is closest to 1, which means that the molecules of the polymer are more or less of the same size and weight. It also implies that this polymer have a trend to have a higher crystallinity, higher rigidity, which means also a higher modulus. So it's also expected to have lower stretchability. A polymer with narrow band type, you also have a trend to have a higher density in comparison to a broad band type.